Hello guys, welcome to the new video. So I've come with a very exciting problem today based on the topic of limits. It's a very good question. There are different ways to tackle these questions. Like all the questions are problem of the day. Like the questions are of which are actually meant for the real mathematics. So that's the reason I only involve most of the questions in the topic of differential calculus and integral calculus, because these are the things that we usually use in the upper engineering and everything. So everything that's gonna be demonstrated using mathematics needs calculus a lot. So that's the reason like people really enjoy solving calculus. So that's the reason I involve most of the topic problems of that topic. And now I've come with the an exciting problem of limits, which is a very good problem. As usual, there are many ways to tackle it, but this is my way so that it actually gives you a correct solution within no time, and also it's one of the best way like to learn and also to apply to any other problems also. So coming to the problem, so this is a problem. So value of a b c such that limit extends to 1 ax power 4 plus bx cube plus 1 divided by x minus 1 into sine pi x. Okay, so exist, and this actually is saying that this exists and is equal to c. So that's the point that you need to actually keep in mind, that this limit is existing and is as this equals to c. So we need to find all these values a, b and c. So the first thing that you need to notice, when I keep 1 over here, okay, when I keep 1 over here, I get a plus b plus 1, isn't it, divided by 1 minus 1 0 sine pi 0, isn't it, sine pi 0. So this is what I'm gonna get. So 0 in the denominator, which is a ruthless thing in mathematics. Like we never expect 0 to be in the denominator. In the multiplication, not in addition or subtraction, in the multiplication or division, we don't want 0 in the denominator. So we actually want to eradicate it, isn't it? So we need to get out of it. So 0 is there, 0 into 0. So the first thing that we usually do is LH rule. But when is LH rule actually applicable is when the numerator is also 0, isn't it? When its numerator is also undefined and the denominator is also undefined, then we use LH rule. But here that's not the case. So what do you do in this type of things is, what you do in this type of things is, first of all, it's 0 into 0. So better make sure like you can convert one term into which is non-zero thing. Okay, you can better convert into non-zero thing. This is x minus 1. Okay, this we cannot even convert into non-zero. How can you even do it? So we will just focus on sine pi x. Okay, so when I consider that, I can even write this whole term as x minus 1 whole square into sine pi x divided by x minus 1, isn't it? So this whole denominator I can write it in this way, right? So I'll just focus on this part. Okay, so limit x tends to 1 sine pi x divided by x minus 1. This is what I'm gonna take and deal. So that I just wanted to change this because it's 0 into 0. Some or the other term I can change into a non-zero term so that I can just proceed further. So that's the reason. So limit x tends to 1 because limit x tends to 1 is 0. So sine pi x by x minus 1. So it is a 0 by 0 form, because when you put 1 here in the numerator, it's 0, in the denominator is 0. So just differentiate it. So when you differentiate it, you get pi cos pi x divided by 1, isn't it? So now just put 1 here. Okay, now just put 1. So you get pi into cos pi, which is equal to minus pi, isn't it? After putting x is equal to 1, you get minus pi. So instead of all this term, like I first written this in denominator in this way, so I'll just convert the whole stuff into this way, right? So limit x tends to 1 a x power 4 plus b x cube plus 1 divided by x minus 1 whole square into minus pi. So this is how I written this. Okay, so just one term I've converted into a non-zero term so that we can deal with this actually. So come to the next page. So if I just put like this, actually he has told us, like in the question it has been mentioned that this limit exists, isn't it? This limit is existing, but here in the denominator we are getting it to be a 0, isn't it? 1 minus 1 whole square, which is 0 into minus pi, 0. So definitely the numerator should also be 0, then only we can gonna get 0 by 0 form and we can go further, isn't it? If the denominator is only 0, we cannot do anything. We cannot even modify this because it's a polynomial function. We cannot do anything regarding that. So x minus minus whole square cannot be manipulated in any other way. So only thing is we can assume this numerator is also 0, so that it's 0 by 0 form. So we can use the LH rule and other rules to actually get into the, like, find the exact limit. So that's the reason. So after putting 1, I need the numerator to be also 0. So I need to assume that a plus b1 plus b plus 1 should be equal to 0. So this is my first condition. Okay, so actually after putting 1, I'm getting a plus b plus 1. So this also need to be 0. So if this is 0, okay, if this is 0 and the denominator is also 0, we can directly use LH rule. So after using LH rule, what do we get as limit x tends to 1, okay, limit x tends to 1, 4a x cube plus bx square into 3 divided by 2 of x minus 1 into minus pi, isn't it? Again, if you put x is equal to 1, okay, again if you put x is equal to 1, you get the denominator to be 0, and the numerator is also 4a plus 3b, isn't it? 4a plus 3b. So again it is 0 in the denominator, so again we need to assume that 4a plus 3b should be equal to 0, isn't it? So because in the first case we have assumed the denominator to be 0, in the second case also we need to assume that to be 0, because it's coming 0 in the numerator. Actually we are getting 0 in the denominator. So for the limit to exist, we also need the numerator to get 0, so that we could actually use rules to demonstrate the limit, actually get the limit. And also if one of the part is 0, okay, denominator is 0, definitely the numerator should be in the range of 0, okay, not, it cannot be defined, it will always be infinity, because in the range of 0 means you can assume the denominator to be 0.00000 something, like it's almost approximately equal to 0. And if any number other than 0, okay, other than 0, if I put 1, it actually comes to infinity, which means it doesn't exist. So that's the reason, but in the question it's told us that it exists, so that's the reason we need to assume that 4a plus 3b, like denominator will also be equal to 0, approximately equal to 0. So this is my second condition. Okay, a plus b plus 1 is 0 is the first condition, this is the second condition. So just solve it. So a plus b plus 1 is equal to 0, so I just multiplied by 4, I get 4a plus 4b to be minus 4, and here 4a plus 3b to be 0. Okay, so just subtract these two, so you get b is equal to minus 4. So when you get b is equal to minus 4, you get a to be 3, right? So a is equal to 3 and b is minus 4. So just substitute these terms in the question. Okay, just substitute these terms in the question. Like again you can use, you must use the LH rule, okay, because it's 0 by 0 form. So it comes out to be limit x tends to 1, 12ax square plus 2 into 3 6 bx divided by, yeah, why is this happening? Yeah, 6bx divided by 2 of minus pi, isn't it? 2 of minus pi. So this is what we're gonna get. Now just substitute 1, you get 12a plus 6b divided by minus 2 pi, isn't it? So what are the values of a and b? 3 and minus 4. You can just substitute that. So on substituting, you get the answer to be 6 minus 6 pi. So the answers are as such. A equals to 3, b equals to minus 4, and c is equal to minus 6 by pi. I hope you guys got it. So it's a very very good problem of limits, like it actually clears many of the fundamentals, like how to deal such questions where one part is not 0 and the other part is 0. I hope you understood, like why we need to assume the numerator also 0 and the denominator is actually 0, because it actually, if it's not 0, okay, if it is not 0, for example, I actually explained you, but once again I'm explaining so that people get extra clarity. Like if I assume some number 4 divided by 0.0000000 till so on, like it's almost equal to 0 and 1, it's actually infinity, right? So this actually means that limit is not existing properly, so that's the reason we cannot do it. So we also need to assume the numerator in that region, that like mean 0.00000 something 3 or something like that, then only limit exists actually. So that's the reason we need to assume the numerator to be also 0 when the denominator is actually 0, and when these both are 0, we can usually use LH rule, so that we can easily come on to the final limit, like answer. I hope you guys enjoyed this. It's a very good problem. So stay tuned. Tomorrow I'll be coming up with giant problems of mathematics. Thank you.